two gears are adjusted so that the smaller gear drives the larger one, as shown in the figure. If the smaller gear rotates through an angle of 300 degrees, through how many degrees does the larger gear rotate? So, okay, the smaller gear is driving the larger gear. And so the key to solving problems like this, where you've got like mated pieces that like the rotations are mated, like these mated gears or mated components, is that so what there's something about these two that this mating makes common. And what it is that the circumference rotations are going to be the same, right? If you think about think about a fraction of a second as these are rotating, the exact distance that this like circumference, they call it a pitch diameter of a gear. That's like what represents the diameter, the circle that is that mates that the activation circle. So in a fraction of a second, for every little bit that this rotates, this gear rotates, this gear is going to rotate that same arc length. And then you can expand that from a fraction of a second to any time. It's going to be the same arc length rotation of the pitch diameter. So that's the key to solving a problem like this. So we know that it's asking this gear rotates 300 degrees. So let's figure out how much does its pitch diameter rotate? How much of circumference is that? And that's going to be equal to this circumference. And as a result, what you can think about is that this is going to have to rotate faster. That's why if you look at like gear trains, gearboxes, etc., the smaller gears everything's mated. The smaller gears are always rotating faster than the larger gears because they have to rotate faster to cover the same amount of circumference. So, okay. With arc length, it's easier to work in radians. So let's convert this rotation to radians. So degrees cancel. 30 divided by 2 is 15. 18 divided by 2 is 9. 15 divided by 3 is 5. 9 divided by 3 is 3. So 5 pi over 3. Okay, so what arc length is that? Well, S is equal to theta R, so that's 5 pi over 3. They're referring to the smaller gear, so 3.7 centimeters. So 5 times 3.7 times pi divided by 3. 19 point, let's carry all the decimals. So 19.3732. Let's carry as much accuracy as we can into the final answer. 19.3732 centimeters. So that means that this gear is going to have to rotate that same, the circumference of this gear is going to rotate that same amount. So how many degrees is that? Well, let's take the arc length formula and do theta is equal to S divided by R. The S's are going to be the same, but the R is going to be different. Divided by 7.1, so 2.72861. That's in radians. Now it wants this in degrees, so there's 180 degrees for every pi radians. Radians cancel, you could say, but there's really no units. So this times 180 divided by pi, so about 156 degrees.